I'm Alan Fessler with TPI, Temp Power Innovations. TPI produced a brief introductory video presentation where we introduced our company and my background. We outlined what we believed was a shortcoming in EPC's temporary power schemes, from safety to aesthetics and reliability to available power capacity. In this next video, we'll expand on the safety features of our products. TPI believes that construction temporary power is ready for a 21st century upgrade. Safety improvements are paramount to the core purpose of this transformation. Current temporary power systems utilize a solidly grounded 480 volt AC system. This is likely because the electrical code that governs temporary power requires an ungrounded or high resistance ground system to have a ground fault monitoring, which is expensive and requires a level of technical expertise to set up and monitor. High resistance ground HRG 480 volt systems with ground detect circuits, post-Glover style, replicates the standard in all newly designed permanent electrical schemes. These HRG systems are unquestionably safer because they reduce fault current, shock current, and arc flash potential of a single phase to ground event. These HRG systems will reduce the severity of shock injury to workers who may come in contact with a single phase of 480 volt, since high resistance ground circuit will significantly restrict the shock current through the worker's body to ground. In the existing temp power solidly grounded system, the worker in contact with a live conductor completes the path from phase voltage to designated low or zero resistance ground. This is one primary reason all new permanent 480 volt systems are HRG high resistance ground. Again, TPI is attempting to duplicate the safety and sophistication of a permanent power scheme. EPCs should not have to compromise or risk safety in this endeavor anymore by using a solidly grounded system. A construction worker is more likely to come in contact with temp power than permanent power, and my temp power HRG could mean the difference between life and death. This is an important distinction of solidly grounded versus HRG systems. Electricity can kill or cause serious injury in two ways: arc flash and electrical shock. Here is an illustration of a typical solidly grounded 480 volt Y-type transformer. The center tap of the transformer is tied directly to ground. If a single conductor comes in contact with ground, the resistance is extremely low and therefore fault current can be in excess of 20,000 amps. This massive current can melt conductors and bus bars, causing molten metal to expand, creating a fireball. The result is a devastating arc flash to workers in the area. The breaker or fuse will interrupt the power, but not quickly enough to prevent an arc flash event. Alternately, if a craft worker comes in contact with any phase of the conductor, he has the potential to receive lethal shock current through his body, again due to zero resistance and high potential current back to ground. With HRG resistor at the center tap to ground, we now limit fault current on a single phase to ground event to less than 10 amps. This virtually eliminates an arc flash in the fault since current is extremely low. In the case of the craft worker contacting a single phase of 480 volt, he will receive a significantly reduced electrical shock since current through his body is minimal thanks to the HRG resistor limiting this current. Chances of surviving is greatly improved. Now imagine an ammeter in series with the HRG resistor. This current can be set to alarm at a threshold value of 5 amps. Alerting our technicians of a single phase to ground fault. Additionally, system reliability improves as the 480 volt power will still function normally with a one-phase ground, with the only known symptom a ground fault alarm.